In this video, I'll be going over a basic rules derivation that is a little bit more difficult than some of the ones we've been seeing in class, so we'll have to sort of incorporate some new techniques. This is using all the basic 10 rules and none of the derived rules. So as always, to start, we start by showing our conclusion. So not S and P biconditional, not Q. I could assume ID here, well, whatever. I will. Not S and bracket P biconditional, not Q. You just never know when you're going to need it, so it doesn't hurt to do it. On line 3, I should take a look. Over here, my first premise is a conditional, my second premise is a conjunction, my third premise is a conditional, and this big thing here isn't very helpful. So it looks like the right thing to do is to split up premise 2. That's quite easy. I'll just write out both sides, R or W, arrow, not S, and on line 4 I'm going to get W or not S, and both of these are done by premise 2 simplification. So this is nice. This is a conditional, which looks useful. This is a disjunction, which looks useful, and I'm stuck. I should see that I've basically run out of automatic moves. Over here I have not Q arrow P. I took care of this premise here. Over here I have not R arrow Q, arrow not P. That's a big conditional waiting to happen. Another conditional and a disjunction. So in this situation, this is sort of odd. I'm essentially totally stuck and not sure what to do. Well, when I'm stuck, I look towards my overall structure of the derivation. And I should quickly realize that one thing I'm going to need to do is show not S, and the other thing I'm going to need to do is show not or P biconditional, not Q. Now, this isn't nearly as bad as it looks. I've just got to do one at a time. Once I show each side, I'll be able to adjoin them to get the conjunction. So I'm going to show not S right now, and on 6 I get S as an AID, or assume ID, and now I finally actually have some sort of atomic to work with. So here I can start playing around. Notice the first premise doesn't really do anything for me. This premise is broken down, so I'm looking over here. Now the S can clearly combine with line 3 and 4. In fact, on line 3 I can double negate S and do a modus tollens to get not R or W, and that is line 3, line 6 double negated, modus tollens. And I should also realize that I can combine S with line 4 because I can MTP this disjunction, which requires me to have the negation of one side. Now the negation of not S is actually not S, so again I just have to be careful. I'll take 6, I double negate it, and then on 4 I modus tollendo ponens, which gives me W. From here I just need to look. The trick with this one is this negation right here means that this line is most likely a contradiction generator. I have to use it to get out of my current show line, and the trick to doing that is build the inside. Well, the inside is a disjunction, R or W, which means all I need is one side. Do I have R? No. Do I have W? Yes. So I can use the good old add rule, addition, to build R or W from line 8, add. On line 10, I can just say, oh look, there's a contradiction with 7, 9, ID, box, and close. Well, so that wasn't so bad at all. This is actually the yellow highlight over here is my not S, and now I just need to do the rest of it. So what I really need to do is show P biconditional, not Q. Now I'm just going to sort of work on the side here and realize if I want P biconditional, not Q, I need P arrow not Q, and I also need not Q arrow P. And so that's typically how a biconditional derivation goes. But look over here. Over here I already have not Q arrow P. Check. So I don't actually need to do that. It was given to me as one of the premises. So all I really need to do is hunt down this. And if I need it and I want it, I just show it. I show P arrow not Q. On line 12, I start with a conditional derivation, so that's assume CD, and then on line 13 I'll write show not Q. So let's start over here. On line 14, my last line was show not Q. Well, then I can get Q as an assume ID. Now again, I don't look at anything over here. This is all used up and it's in the box. I can't do anything to it. So now I just basically look at Q and I try and combine it with what's on the board. Well, I can't really combine it with line 3 or line 4. Actually, I also have P. So there's no P's or Q's anywhere here. In fact, the only area the P and Q appears is right here. So I'm looking to build the antecedent, or I'm looking to have the negation of the consequent. Well, it's pretty clear that I have the negation of the consequent. I have P, and that's not P. So of course I'll need to double negate it, and then I do a modus tollens, and I get the following. And that is line 12, double negate, premise 3, modus tollens. Now again, the trick whenever you see something like this in all basic rules question is that this is a contradiction generator. All I need now is to show not R arrow Q and I'm done. When I want to show something, I write it. Show not R arrow Q. 17, not R, that's assume CD. Now I could write at this point show Q, then assume ID not Q, but I don't even need to do that. I actually realize right here on line 14 I have Q. So all I'm going to do is write 14, repeat, and then say, hey, that's a conditional derivation. I have shown the consequent. So I just sort of skip some lines here that aren't useful because I actually already did the work. Now that I've shown not R arrow Q, that is the contradiction right there on lines 15 and 16. So I'll say 15, 16 in direct derivation, and I get to cross off my last show line. I've now shown not Q under the assumption of P, which means that I've actually shown P arrow not Q on line 20, and that is 13 CD. Now looking up here at my sort of like diagram, I have now shown this, and I want the biconditional, so I'm set. I can build the biconditional, P biconditional not Q, from line 11 as well as premise 1, conditional to biconditional. The last thing I need to do to finish the proof is actually get the current show line, which is the not S and this. Well, I have the not S and I have the P biconditional not Q, and so I'm ready to adjoin them. Not S and bracket P biconditional not Q from lines 5, lines 21, and that is a adjoin. And I can say direct derivation because it's exactly what I was looking for. So just a couple comments on this derivation. It's not particularly difficult, but there are lots of steps. The first thing is we did some automatic moves, and the automatic moves did not actually yield too much, but we needed to do them. After we did the automatic moves, we looked towards the structure of the derivation. The structure of the derivation said if I have a conjunction, I need to show both the left side and the right side of the conjunction. So first I showed the left conjunct, which was not S, and then later I realized to show the right. When I actually showed not S, I encountered things that look like this. Not bracket R or W. If I have the negation of a connective and I cannot get at the inside, I use it as a contradiction generator. That was my clue that I really wanted R or W. The other trick here was I applied some additional sort of structural knowledge. If I want to show the biconditional over here, I realized that what I needed is to show it both ways. So I just looked around and realized that I had one of the ways already in my first premise, so I really just needed to show the other way, which is what I did here. Once I had it, I knew to make it into a biconditional, and then I knew to join it into the conjunction to get the proof finished. Students might struggle here in trying to figure out how to implement show lines to get them out of binds, but it's very straightforward. I use show lines as dictated as the structural elements of my proof, which was a conjunction and a biconditional down here, and I also use show lines in instances where I needed to generate the contradiction, which is what I did over here. If I wanted not R arrow Q, I just showed not R arrow Q. Okay, lots of things to think about in this. Good luck.